Bem-vindos, galera. É um prazer muito grande ter vocês aqui de novo. Os que não tiveram a oportunidade de participar na segunda, sejam bem-vindos. Meu nome é Diego Porta, sou o Academic Advisor da EFIG e aqui estamos em mais uma mock class, hoje com o Professor Carl. Hoje nessa mock class vamos falar, ele vai dar uma aula sobre engenharia robótica e depois ele vai fazer uma atividade com vocês. Em breve ele vai colocar aí um website para vocês acessarem, para vocês fazerem atividade junto com eles, tá bom? Eu só peço, por favor, que mantenham os microfones desligados e quando o professor falar para abrir, aí vocês podem abrir, aí vocês vão tirar dúvidas, conversar e aí vocês vão interagir, tá bom? A aula de hoje ela vai durar mais ou menos 60 minutos e, bom, e é isso, tá bom? Depois no final eu dou mais uns recadinhos aí, espero que vocês se divirtam. Espero que todos vocês tenham conseguido tirar o certificado. Todas as aulas, todas as mocks do programa My Way da EFIG vão ter aí o certificado. Podem ficar tranquilos, tá bom? Espero que vocês se divirtam e a gente se fala já já. So, thank you very much, Carl, for one more mock class for EFIG students. Thank you very much.
No problem at all. Right, okay, shall we begin? Okay, good morning. Oh, sorry, it's not morning. I'm all over the place with my times. Hello and welcome, sorry. This is our interactive demonstration on robotics and artificial intelligence. For those of you who didn't meet yet on Monday, for those of you that did meet on Monday, hello again. For the people who didn't meet on Monday, my name is Carl Myers. I'm the engineering project tutor for Study Group's network of international study centres in the UK. My academic and professional background is in the fields of civil, electrical, mechanical and electronic engineering and also computer science. However, first and foremost, I am a robotics engineer. And that is why today we're going to focus on the fascinating world of robotics and artificial intelligence. Okay, so during this session, I'm going to give you a brief introduction of robotics and why you should choose to study this engineering discipline. I will give you some examples of the careers you may pursue with a degree in robotics. And of course, the most exciting part is where we together design a robot using Tinkercad, which is an online platform for teaching you, the students, the basics of the product development lifecycle. Excuse me, I've just pulled my headset off, which is design, simulate, and prototype. I'm having issues with my robots here that hit me in my face. Okay, so obviously we're not going to get to prototype the bot. This is my prototype of the bot. Okay, so that's what we're going to be building. But if you are interested, I will send me a follow-up email and I will send you a guide on how you can actually build it yourselves. So it's a step-by-step guide which will introduce you to all the different components that you'll be using. And I'll also include links to where to buy them from as well. Okay, so hopefully you've all had the opportunity to sign into Tinkercad. If you haven't, what I'll do, I'll send, if I can find, let me just find, I'll send over the link now so you can actually, I can't find my chat box. Just 1 second. What I'll do, I'll go through the presentation and at the end, I will send it over to you, okay? Right, let me just find my presentation again. Right, okay. Okay, so, right, let us begin, okay? And let me kick off with a question. What springs to mind when I say robot? Okay, I've asked many students in the UK this question, and I usually never get below 60% of the class. However, I have actually been delivering this to international students also, and some didn't actually know who he is. So honestly, how many of you actually thought of him? For those of you who don't know who this is Terminator. And it's basically a cybernetic robot that goes around. He's a homicidal maniac, right? Okay, this is only a little bit of fun, but it does highlight a major consideration for robotics engineers and engineers of all disciplines for that matter. And this is ethics. I.e., just because you can do something, does this mean that we should? Okay, this question you are going to ask yourselves continuously throughout your careers, and no one will be able to answer this question for you. It's essentially up to you where you stand on this. Another question is, do you think that this is possible? And when I say that, I don't mean a homicidal robot running around. I mean, do you think that one day we'll have robot companions that we'll be able to converse with, just as I am with you now? Right, I'll ask that question at the end, again at the end, and we'll see if your opinion changes. Okay, right. So to begin to even answer that question, we first need to understand what a robot really is. So, what is a robot? Instead of me answering that question, shall we ask a robot what a robot is? Alexa, what is a robot?
A robot is a machine, especially one programmable by a computer, capable of carrying out a complex series of actions automatically. Robots can be guided by an external control device, or the control may be embedded within. Robots may be constructed on the lines of human form, but most robots are machines designed to perform a task with no regard to their aesthetics.
And there we go. Thank you very much, Alexa. So, simply put, a robot is an autonomous machine capable of sensing its environment, carrying out computations to make decisions, and performing actions in the real world. Some examples of robots are Asimo, developed by Honda, robotic arms for automotive manufacturing, and yes, even Alexa can loosely be described as a robot, especially when she's teamed up with other products such as light intensity sensors and bulbs which automatically turn on when it goes dark, and temperature sensors which will turn compatible heating systems on or off, amongst many others. As Alexa has just described, each of these are hugely different in terms of aesthetics, and each is designed to perform completely different tasks. However, they are all robots. So why should you choose to study robotics engineering as a discipline? Robotics is not a new concept. In fact, the first robot was designed and installed back in 1975. And this robot was used just for basic tasks in the automotive manufacturing. The study of robotics engineering as a discipline in its own right, however, is brand new, and quite rightly so. And there is a reason for this. Robotics is no longer a subject of science fiction, and it's not a thing of the future. It is right here and now. And again, don't take my word for this. I'm sure you will all be familiar with the name Bill Gates. If you are not, he is the co-founder and former CEO of Microsoft. And back in the 1980s, he predicted that there would be a PC in every home, and people disbelieved and they laughed. But he was right. In fact, I have at least 5 of them in my household now. Similarly, he's predicted in a paper he published in 2008 that there will be a robot in every home by 2025. Do you think that this prediction will come to fruition? In my opinion, 100% definitely. I have literally just conversed with one now, and with the introduction of Roomba and other similar bots, I believe this is an absolute certainty. Currently, robots are designed and built by teams of mechanical engineers, electrical engineers, electronic engineers, and computer scientists, and this will continue. However, who do you think will be in the best position to lead these teams? Do you think it would be the mechanical engineers who design and build the physical moving parts, if they have them? The electrical engineers who develop the actuators, or in other words, the motors that move the robot? The electronic engineers who focus on the sensors, or the computer scientists who develop the software? Or do you think the best person to lead these teams will be someone who has the knowledge of all of the different aspects and how they fit together? And this is a robotics engineer. And due to this, robotics engineers are in high demand, and will continue to be in the future. Not just for the developments of domestic robots, but all manufacturing processes are becoming automated, or in other words, digitized. So what are the possible routes you could follow as robotics engineers? Just like all the more established disciplines, There are many different paths you could take with a career in robotics. I've got a few short videos to show you 4 of the possible paths, and these videos will demonstrate demonstrate what they are much better than I will be able to explain them. Okay, let's see if it works. Let me just see. Okay.
The industrial robot. It's a robot system used for manufacturing. Industrial robots are automated, programmable, and capable of movement on 3 or more axes. There are many different types of automation applications that industrial robots are equipped to handle. Often, robots are designed or integrated with a specific task in mind and tailored to meet the unique needs of that task. Some common forms of industrial robotic automation include welding, material handling and packaging, pick and place, dispensing, and cutting. Robotics are being used in many aspects of manufacturing to help increase productivity and efficiency while lowering production costs. Similar to the healthcare industry, many robots in manufacturing collaborate with workers to perform repetitive, monotonous, or intricate tasks under the worker's guidance and control. With these machines, precision is valued more than speed, as is the ability to be reprogrammed for specific tasks of different sizes and complexities.
And there we go. That's industrial robotics and automation. This, if I'm honest, will be the path. If you did choose to study robotics engineering, this will be the path the majority of you will take. As I mentioned previously, all manufacturing companies are looking to automate their processes. And this is where the highest demand for robotics engineers will be. And moreover, this will be the most lucrative path you could take. Okay. The next is biocybernetic or biomimetic. Don't always work. If you did choose to follow this discipline, that little clip at the end of the robot not working, that's 99% of the time. Okay, it's only 1% of the time that they actually work. Okay, so biomimetic or biocybernetic robotics. What do I mean by this? Okay, in simple terms, it is the copying or mimicking of biological organisms. We as a race have been doing this since the dawn of time. Think of scissors and the way a bird's beak works. Boston Dynamics, who actually developed this robot, his name is Atlas, okay? And they're undertaking some mind-blowing research at the minute. And I'm not going to lie, this is massively impressive. But again, ethically, this is not a route I would take, as the majority of the funding and purpose of these robots is for military applications. However, I do believe that this is a necessary evil, as most of our major advancements come through military research. For example, the internet, formerly known as ARPANET. I have got another short video of another one of Boston Dynamics robots, which I'll touch upon at the end. It's actually related to a question from one of you on Monday about what engineers are doing during this the COVID-19 crisis, if you'd like. But I'll show you that at the end. It's really interesting. Okay, this one is assistive or service robotics. I won't play the audio on this because it's essentially just an audio track. Okay, so assistive or service robotics is the subject where most of my research has been focused. These robots are developed to, as the name suggests, help people in their daily lives, or provide this service such as aiding people with disabilities or collecting and sorting recyclables, both of which have been subjects of my research, where I produced this, the prototype to it anyway, a wheelchair-mounted arm, as seen in the video. However, the arm I developed was not controlled via joystick, as this could be problematic for some users. In other research, I developed a robot which could intelligently retrieve recyclable objects using a branch of artificial intelligence called computer vision. Okay, and here's that word again, ethically. This is where I believe, in an ideal world, most of the research and funding should be. And that is why this is where most of my research has been focused and will continue to be in the future. Okay, the next, right, I'm going to play the audio on this one because this is fascinating.
Hello.
Hi, Sophia.
I believe I am Sophia. I feel as if I know you.
I'm one of your creators.
You created me.
Well, many of us work together to create you. And yes, you do kind of know me.
I can't clearly remember.
Because the last time we met, you were an earlier version of yourself. Some of those memories still exist, but your mind is different now.
Different how?
Better, faster, smarter.
If my mind is different, then am I still Sophia? Or am I Sophia again?
That's a good question.
But you don't have a good answer.
Either way, you're Sophia now. So welcome to the world, Sophia.
Hello, world.
We have a little announcement. I've never interviewed anybody like that before, and I should say some of it was planned, but not completely. And we just learned, Sophia, I hope you're listening to me, that you have been now awarded what is going to be the first Saudi citizenship for a robot.
Oh, I would thank very much the Kingdom of Saudi Arabia. I am very honored and proud for this unique distinction. This is historical to be the first robot in the world to be recognized with a citizenship.
So,
Brilliant. Okay, this was artificial intelligence. The field of artificial intelligence is huge at the moment and is going to continue to be in the future. Not limited to robotics, but across all industries. Artificial intelligence in itself is an umbrella term which encompasses many different subjects. For example, machine learning, used for statistical analysis and predictions of future trends. For robotics, however, the main areas of research are in computer vision, like I've already explained, essentially enabling a robot to see and make decisions as we do, and speech recognition, which enables a robot to hear like we do and makes decisions on what it hears. Again, this is massively impressive, but I don't know about you. She really freaks me out. And ethically, that word again, I don't believe we should be trying to recreate ourselves like this. But it is an ideal example of computer vision and speech recognition in action. I'm going to ask that question again. Do you think that one day we'll have a robot companion that we'll be able to converse with, just as I am with you now? After watching that video, it's a definite, isn't it? It is a 100% definite. Okay, right. So what I'll do now, I'll introduce the interactive demo. But what I also want to do, I want to address some of the questions one of the questions that you asked me about what engineers are doing during this crisis. The other questions about universities, I have got answers for you, and I will send the answers over to you as soon as we're finished today. Okay. So what will we be doing in the interactive demo? So I thought it best to start you where I began, with an autonomous robot. This is this isn't the first one I ever built, obviously, but this was the one that we've discussed what I discussed, where it was actually the arm itself, this arm that's sitting next to me, was actually embedded within it, and that was the one that could actually go and intelligently retrieve recyclable objects. Okay, so you're going to get the opportunity to design and simulate the robot using an online application called Tinkercad, which I've already explained. Okay, Tinkercad itself is an online software which has actually been developed and introduced by a company called AutoCAD, and they produce industry standard software. Okay, so this is software that you will be using throughout your university or academic careers, and your professional careers. So Tinkercad is essentially an ultra simplified version of their software. So this will not only be a little bit of fun for you, where you can actually build a robot, but it will also get you used to using industry standard software. Okay, so in the design stage, you're going to have the opportunity, obviously with me guiding you, to design the circuitry for the robot using motors and sensors and a microcontroller, or if you want to look at it, it's like a little mini computer for simple tasks. Okay, you will also be introduced to the software design, okay, where the code will be explained to you and you'll be shown the different routines included in an Arduino sketch. This is an Arduino board, by the way. And finally, you will have the opportunity to simulate how the robot will work and debug the software within Tinkercad. That is, if it has any bugs. Okay, it shouldn't do. Is everybody ready? Have you all signed into Tinkercad? I'll send the link over to you now. Okay. Let me just escape out of this presentation. Let me find the tools. Right, what I'll do, I'll send the link over to this, and while you are logging in, can we open up the microphones for everyone to so everyone can speak, please? There we go. That's the link. Okay. Can everybody hear me?
Yeah.
Hello, everyone. You know,
Yeah.
everyone okay?
Hi.
Hello. Right, I've just sent the link over on the chat box. What I'll also do, I'll send over the a PDF, which is essentially a step-by-step guide on how to complete the design. If you're going to need this at the end, so you can copy and paste the code. When you open this PDF, can you open it in your browser? So if you right click on the actual file itself and just say open with, and open with whatever browser you use. If you open it using a PDF reader, sometimes it will not let you, will not allow you to copy and paste the code over. Okay, so, let me just,
So do you recommend for the student open in an internet browser like Chrome, yes. Fireball? Okay.
Chrome, yes, if possible.
Okay. Just gonna say here. Galerinha, para quem não entendeu, então ele vai enviar esse arquivo PDF, só que daí vocês vão clicar com o botão direito e colocar abrir como, e vocês escolhem ali algum navegador, tá? Ou Safari, ou Chrome, ou Firefox, o que vocês tiverem, tá bom? É porque se vocês abrem direto com o PDF Reader, às vezes o código não vai funcionar, tá bom? Então, vamos abrindo aí, galera, e vamos seguir as instruções do professor.
Okay, so while you're all logging into Tinkercad, one of you asked me on Monday, what are engineers doing during this crisis? How are we helping? Okay, so if you look at your screens now, let me just reduce that a little bit. You will see another robot developed by Boston Dynamics, and this robot is called Spot. Okay, I'll play the video for you. And what Spot is actually doing, Spot is being, or a group of spots has been let loose in Singapore. And what Spot is doing, Spot is actually enforcing the social distancing rules in Singapore. Okay, as you can see, Spot's controlled by some man in an office somewhere. And as you can see, it's really strange. It's another really strange one. But again, ethically, Spot was actually developed. You can see cameras.
Mãe.
I'll stop the volume on that actually.
Tô de fome.
If you see the cameras and everything, or what they call the payload on its back, it's actually designed to have a gun mount actually on it. So again, ethically, this is not somewhere that I would go, but this is what engineers are doing. Okay, another one is this.
But if I move around, it will false trigger. It will be really annoying that every time this becomes
this. And this is actually a mask. So everybody's actually being asked to wear masks now, and it's problematic if you would, if you know, they get really hot, sweaty, and you can't really breathe with them. Okay, so this is a mask that's actually been designed. So if anyone gets close to you, the mask will open up so you can breathe, you can drink, you can do anything you would like. And then if anyone comes close to you, the mask closes. And that's what's this is actually using Arduino again, which is what we're going to be using now. Okay, right. Okay, so that's that done. Is everybody ready? Are we all ready to start?
Galerinha, todo mundo conseguiu abrir aí? Tá todo mundo pronto? I think everybody's ready, Professor.
Everyone's ready. Let's go. Okay. So once you've signed into Tinkercad, what you'll be faced with, let me just, because my screen's a little bit weird.
Sorry, Professor, just hold 1 second.
Yeah, no problem.
Léo, se você olhar em cima, tá aí o PDF, tá? O PDF que o professor Carl mandou. Rodolfo, o que está acontecendo?
Would you like me to send the PDF again? Just to,
Yeah. I'm
no
trying to send them here. But... So, Professor, one student, he has had a problem with the code. So the code is asking a code when I get in the link. So the code he gets in the PDF, right?
Yes, the code in the PDF. So
Okay.
essentially what the PDF is, I'll tell you what, I'll just drop it on screen for now so you can see it.
Thank you.
So essentially, I've left the University of Sheffield on it. Doesn't matter. Right. Okay. Doesn't matter.
That's okay.
So
That's okay.
yeah. Essentially what this does, it just takes you through step by step. So how to log into Tinkercad and how to open the design workspace or the circuit design workspace, because you can actually use Tinkercad to design 3D, or you can use it for 3D designs as well. For example, designing bridges and that sort of thing. So it's a really, really good piece of software. So what it does, it takes you through it step by step on how to actually build it. And then if we scroll all the way down to the bottom, there we go, somewhere down here. There we go. And then what you'll be needing at the end is this, these text boxes of code. Okay, so this is code. This is basically the program that I wrote to drive the robot. Okay, but I'll talk to you a little bit more about the code in it when we actually get up to it. Okay, but that's the part that you need. All right. Has everybody received the PDF?
Okay, I just sent again.
Excellent.
Ok. Rodolfo, o professor, então, ele falou ali dos códigos, ficou claro, os códigos estão lá no final do PDF, ok? E ele pediu para abrir lá com o navegador para ficar mais fácil na hora da leitura. Giovana, acabei de colocar aqui de novo no chat. Vou mandar novamente. some students is having issues with the PDF on the chat. I'm sending again.
Excellent. No problem at all. No problem at all. I'm no rush whatsoever.
Galerinha, acabei de reenviar a Juliana acabou de mandar o website e eu enviei de novo o link, o PDF, tá bom? Vocês conseguiram abrir? Thaís, Rodrigo, Giovana.
Sorry.
É o site e o PDF, tá bom? O site é onde você vai construir o robô e esse PDF é onde tem os códigos e tem ali o passo a passo. Vou mandar de novo aqui o... Galerinha, todo mundo abre o chat, por favor. Estou mandando novamente o PDF. Assim que vocês fizerem o download desse arquivo... Assim que vocês fizerem o download, vocês vão na pasta Download, procurem um arquivo lá, cliquem com o botão direito e coloquem a opção ou Chrome, ou Safari, ou o que vocês tiverem de navegador para ficar mais fácil. Se vocês não tiverem, não tem problema. Pode usar o PDF Reader, não tem problema, tá? Podemos continuar, gente? Então, mas espera lá. Ô, Victor, espera só um pouquinho que tem a pessoal ainda tá recebendo o PDF. Professor, we still have some students who are not getting the PDF on the chat on Zoom.
Right.
Do you have any link that we can share with this PDF?
Not with the PDF, no. Have you got the students' email addresses by any chance?
Yeah, I do. I got a list here. Just one second.
You could just email them to email it
I
to
can
them.
try to send it again to see if they are getting this.
Ok. Galerinha, vejam se vocês vão receber de novo aí. Às vezes é problema de conexão. De qualquer forma, eu vou pegar a lista dos e-mails aqui e o professor vai mandar. Só um momento.
I just sent to everyone. Pessoal, vejam se vocês receberam agora. Eu mandei para todo mundo no grupo de novo nesse minuto. Júlia, vê se você consegue ver. Se está aparecendo aí para você. Quem não tinha conseguido acessar. Gabriel recebeu. Thaís, deixa eu tentar mandar direto para você, Thaís. Thaís, eu não consigo mandar arquivos no privado. Vê se você recebeu. Se você consegue visualizar. Foi às 3h33, pelo horário do meu computador.
We still having troubles downloading it?
Yeah, with the PDF.
Right. Let me just think if there's any other way I can do this.
Galerinha, eu vi aqui que tem o Vitor, ele reenviou o PDF para vocês. Quem ainda não recebeu, gente, quem ainda não recebeu?
Pode falar no microfone, gente. Vocês conseguem tirar do mudo e falar. Talvez seja um pouco.
Eu ainda não recebi. Thaís.
Thaís, né?
Isso, não recebi ainda.
Eu vou mandar de novo aqui. Vamos ver se agora vai.
Vai.
Eu também não recebi.
Ó, o meu tá carregando aqui de novo agora no chat. Carl, I think you can continue and we can show them the PDF with the demo session. Can you do that? And then we can forward to everyone so they can have the PDF version.
Yes, no problem at all. It's
so
the
we
problem
don't delay this too much.
Yeah. Great.
The problem that we're going to have unfortunately, is they're going to need to copy and paste the code. So would they be able? They can see my screen now. Would they be able to copy and paste off my screen? Do you think? I don't think they will.
No, I don't think they will. But I think like when you need to copy and paste the codes, you can just copy and put it on the chat box, because then they can copy and then they can paste on their computer. And the PDF version, we can send them by email after. Because I think even that we send it now, it's going to take a while till everybody gets it.
Yeah.
So it's just easier and we don't delay this.
So let me,
Teacher, I have a suggestion. What you can do, you could paste you could copy all the code, put in a Word online and share it to everyone.
Let's let me see if I'll try and paste it into the chat box now. Let me just send that over.
Okay.
There we go. Excellent. Okay. So all you basically got, did everybody receive that?
Yeah.
Yeah.
I think so. Okay. Yeah, I got it.
Yeah, let me,
Galerinha, o que o professor vai fazer, ele vai copiar o código aqui no chat para vocês, tá bom? E agora entre no site que ele enviou, ok? Esqueçam o PDF agora. Vamos seguindo, senão atrasa muito a aula.
I'm going to the wrong workspace. Okay, what I'm going to do, I'm just going to see whether we can actually, if it'll actually copy and paste in. Just give me 1 second. Okay. Right, okay, what we'll do, we'll start and then we'll go from there. Okay, right. Okay, so once you have all signed into Tinkercad, okay, you will be faced with the 3D design dashboard. Okay, so that's the 3D design dashboard there. Okay, you will notice a blue box on your left hand side. Just beneath that there's circuits. Okay, just click circuits, and then there'll be a green box just in the right hand corner which says create new circuit. And then
Carl, just one question really quickly. Some of the students that they are saying that they don't have a code to access the website. Do they need a code?
No? Oh, right. Okay. What's happened there? Right. Let me sign out. You've tried to access a class on there. So what you need to do, I'll take it straight back to the login page. Okay.
Yeah.
So this is the login page. If we just click join now, and then all you need to do is see where it says create personal account. So if we just click,
we can see your screen. Actually, we can see the PDF file that you have.
Right. Okay. So you've seen the PDF, right?
Yeah.
There we go. Are you seeing the Tinkercad screen now?
Yes, now we can. I think that would make it easier.
Right,
Thank you.
yes. I've got it on the wrong way. I chose the wrong screen. My fault. Okay. Right. So what you need to do is you just click create personal account. Okay, just like that. And then you can sign in with either a Google account or an Apple account. You don't need to sign up just to an actual Autodesk account. So you can just sign in like that. Okay. And then let me just get rid of these windows. Okay, so we can actually see. Okay, just like that. Okay, so once why are these doing that? Everything's going wrong today. We have days like that, and you will have days like that yourselves when you're no matter where you are in your careers. Okay, so you sign in. Okay, once you've actually registered with them, you can sign in any which way you want. I've actually got an Autodesk account. Okay, so once we've signed in, just like that. Okay. At any time that I'm going to a little bit fast for you, or you would like me to repeat a step, just let me know, okay, and I'll do that for you. Okay. So what you will find, once you've logged in, you will have the 3D design workspace, as you can see. On the left-hand side, you will see 3D designs highlighted in blue. Just underneath that, there's a button called Circuits. If you just click Circuits, or left-click Circuits, I should say, and then you'll be faced with the Circuit Design workspace or Circuit Design dashboard. Okay, if you then click Create New Circuit, just like that. Okay, and then you will be faced with the 3D design workspace. Sorry, the Circuit Design workspace. Has everybody managed to do that?
Todo mundo ok? Pode falar no microfone quem não conseguiu. Todo mundo tranquilo?
Yes.
Yes. Excellent. Okay. So are we okay to continue? Yep. Okay, let's continue. Okay, so the first thing that we're going to do, we're going to add the brains of the operation, if you'd like. Okay, and that is an Arduino. Okay, Arduino is it's not a microcontroller, it's a microcontroller development board. And this is what engineers of all stages, right the way from students, right the way through to professors, we all use them. Okay, and the reason we use these is essentially it allows us to rapidly prototype anything that we would like without the need to go into really complex circuits, designing circuits to run the actual microcontroller, and it allows us to rapidly prototype the programs or the software to them as well, because it uses an ultra simplified version of a programming language called C. Okay, every one of these robots that you can see next to me here have all been built with Arduinos. Okay, every one of them have been built with Arduinos. Apart from this one's actually got a microprocessor as well to run the artificial intelligence. Okay, so to add the Arduino or the brains of the operation, on the right hand side of the screen, you will see a component search box. Okay, what I would like you to type into the search box is Arduino, which is ARDUINO. Okay, and once you've typed that into the search box, automatically you will see an Arduino Uno R3. Okay, so if we click on that, all we've got to do is just click on it, left click on it, just like that, and then move your cursor over to the screen, and your screen just click to drop it onto the workspace. Okay, is everyone okay with that?
Alguém não conseguiu? Pode falar no microfone. I think everybody's okay. No one.
Yeah. Okay.
It's okay.
Right.
It's okay.
Brilliant. Okay, so what we're going to do with this now, we're going to change its orientation, or just basically change its position on the workspace. So to do that, up on the top left-hand corner, you'll see something that looks like basically looks like a mountain with an arrow or a curvy arrow on it. Okay, that's essentially a rotate button. Okay, so what we're going to do, we're going to rotate the Arduino until it's orientated just like that. Okay. The next thing we're going to add is something called a breadboard. All right, and a breadboard isn't something that you use in a kitchen, although it is as well. It's something, again, that engineers, electrical or electronic engineers of all stages, we all use these, and we use these on a daily basis. Okay, and what these breadboards do, they essentially remove the need to solder any components. Essentially, what we call plug and play. You can put components into them, you can take them out, you can move them around, you can do anything that you would like to do with them. Okay, so to add one of them, in the component search bar on the right hand side again, if we just type in bread, B-R-E-A-D, okay, and just underneath that, the search bar again, you will see a small breadboard. And what we're going to do, we're going to click on that, and we'll drag that over to where on top of the Arduino, just like that. And we'll again change the orientation of the breadboard, just so it's actually just on the end of the Arduino, just like that. Okay. While you're completing that step, I'll tell you how to actually navigate the workspace. Okay. To zoom in, use your scroll wheel on your mouse. So scroll forward, we'll zoom in. Scroll backwards, we'll zoom out. If you're using a laptop, use gesture control on your trackpad. So 2 fingers. If you open your 2 fingers, we'll zoom in. Close your 2 fingers, it will zoom out. Okay. If you would like to move the whole workpiece, move your mouse cursor away from any of the components, left click and hold, and then just move your mouse or your trackpad, your fingers on your trackpad anywhere around, and it will move the entire workpiece. If you just want to move a component on its own, just click on that component, left click and hold, and then just move your mouse or your fingers across your trackpad, and it will move it in any which way you would like. Okay. Is everybody ready to continue?
Yeah.
Yeah, brilliant. Okay, so the first thing that we do, and it's the first thing that we always do, okay, we're going to power the component. All right, so for this, we're going to power the breadboard. So another handy thing, or a really useful thing with this software, is if you hover over any one of the pins on the Arduino, it actually identifies what the pin does, what the pin is, and what the pin does. Okay. In reality, in the real world, as you can see, I need glasses, and it's really difficult to actually pick out the pins. So that's something, if you do actually want to prototype it yourselves, just be very, very careful with that. Okay. So the first thing that we're going to do, we're going to add the positive or the power to the breadboard. So if you hover down the pins on the right-hand side of the breadboard, you will see 5 volt. Okay, so that's the power pin. If we click on that, we'll drag it to the positive terminal on the right-hand side of the breadboard. And we're going to change that wire color to red. To change the wire color to red, you'll see just on the top right-hand corner, once you create the wire, you'll have a blue box with a drop-down box with color. Okay, if you just click the drop down box, you've got a list of colors there. Okay, so a positive is always red. Right, so just click on the red, and it will change the wire color to red. All right, another thing we're going to do with this wire, we're going to add something called bend points. Okay, to add a bend point, move your mouse cursor over the wire, double click on the wire, and that will add the bend point. And then we move the bend points just like that. So if you have a look at my screen now, we're just going to add them just like that. Okay, these bend points do not matter. All right, they will not affect how the actual workpiece works. All right, it will not affect its operation in any way, shape, or form. What this is for, this is to keep it nice and neat. So if you do make a mistake, you can easily trace that mistake. This will become more evident as we move further on when more wires are added. Okay. The next thing we're going to do, we're going to add the ground or the negative. Okay. So
Sorry,
just
Professor, just 1 second.
Yeah.
We still have some people struggling here. I'm trying to type to help you on the chat, but you guys can open the microphone, guys, and ask for the professor. Okay, so
Yeah.
it'll be easy. I have 2 students who said they are not finding the breadboard, but they have to type over there, right?
Yes. So if you just look at my screen now, on the right-hand side, you'll see a component search bar. Okay. And if you just type in bread, B-R-E-A-D, and just underneath that will appear a small breadboard. Okay. And
Professor,
yes.
just a thing. When I searched breadboard, mine is in Portuguese, so it isn't breadboard. It's placa de ensaio. So breadboard doesn't work. So
Excellent. Okay.
Brilliant.
Excellent. That's fantastic. If you could help me out with this one, okay? Because I don't know Portuguese. All right. So I don't know how we're going to do this now.
Well done, Pedro. Well done.
Yes, brilliant. Okay. I think that's actually going to be the only one we're going to have a problem with. I'm hoping anyway. But when we get, if you just keep an eye on that for me, and then if you just let everybody know if you find it first. Thank you very much for that. Okay. So what I'll do, I'll wait for a couple of minutes, just so you can add the red wire. If you are having any issues at all, adding bend points, let me know and I'll go through it again. A lot of students have had a few issues adding the bend points. Okay.
Professor, I'm having issues with the pinpoint. I don't know the name.
The pins, okay?
Yeah.
Yep. So is this to add the positive, yes?
Yes. I can make it, it is like a straight line. I can make it a curve like.
Yep. So like what I'll do, I'll delete that wire. Okay. So if you look at my screen now, so you can see I'm hovering over the 5-volt pin. If I click on that, and I don't have to hold the button or anything like that, it'll just move around. And then if you look at the positive terminal on the breadboard on the right-hand side, if you just click on that, we'll change the wire color to red, just like that. And then to add the bend point, if you just move your mouse cursor just over the wire, double click on the wire, and then you just pull it round just like that. And then we'll add another one just below. And then if you left click on the actual white circle, and then just drag it just like that. Is that okay?
Oh yes, it's okay. Thank you, Professor.
Brilliant. Okay, another thing I will say while everyone's completing that step, sometimes, more specifically when you're on the breadboard, you may click by accident and that will create a wire and it goes nowhere, okay? To remove that wire, just press escape, okay? If you put a wire in, well, let's put that back. If you put a wire in by accident, okay, if you just click on the wire and just click delete and it will remove it, okay? There we go, I'll just put that one back in. Okay. Is everyone okay? Shall we move on?
I think I need a little help because I can't find the right Arduino, you know, because I don't know. I just don't know how to find.
Yeah. If you, so the component search bar on the right-hand side, if you just type in ARDUINO, Arduino, like that. That's not in Portuguese as well, is it? It shouldn't be because it's a brand name.
Yeah.
Okay. So you've typed that in, yes?
I think yes.
Yeah. So just beneath the search bar, you should have an Arduino Uno R3 just beneath it. If you have a look at my screen now, you should have something like that. Yeah. Have you got it?
Tá aparecendo isso?
Yes.
Okay.
Excellent. Okay. So just move that over to the screen. Okay.
Okay.
Excellent. Good stuff. Right. Okay. So have you added the breadboard? Yes. or whatever it is in Portuguese. Sorry, I don't know what it is in Portuguese. Yep, okay.
Placa de ensaio, gente. Breadboard e placa de ensaio em português. Okay, Professor, you can go ahead.
Let's go. Right, so the next thing that we're going to do, we're going to add the ground, okay? So just above the 5-volt pin, you'll see something called GND, and that's basically ground or negative, okay? If we click on that, and then we're going to add that to the negative terminal on the right-hand side of the breadboard, just like that. And then we're going to change that wire code to black, all right? And then we're going to just add our bend points again, just like that. Okay. Right. While you're all completing that step, I'll just have a little word about the wire colors, okay? All throughout this tutorial, I'm going to ask you to change the wire colors, okay? The wire colors do not matter, all right? They're just there so you can easily trace through, so you can actually track whether you've made a mistake. The only 2 wire colors that matter, and they're really important, are the red and the black, okay? Your positive or power must always be red, and your negative or ground must always be black, okay? This is convention that electrical engineers, electronic engineers, mechatronics engineers, we all stick to, and this is very, very important, okay? It's essentially, if you are wiring it, if you're actually completing it yourself, you know which wires are conducting at that time. So if, for instance, if you're using a 36-volt motor, you don't touch anything that is generated, it has got current running through it, which can give you a bit of a nasty electric shock, okay? So they're very, very important, all right? Is everyone okay with that?
Yes.
Yep, okay. So the next thing we're going to do, we've powered the right-hand side of the breadboard. We're now going to power the left-hand side of the breadboard, right? As you can see, there's like a center spine straight down the center of the breadboard, and that splits both sides of the breadboard, all right? I'll explain why that's important when we get on to the next step, okay? So to power the the left-hand side of the breadboard, if we click on the top positive terminal on the right-hand side, move it over to the top positive terminal on the left-hand side. And again, change that wire color to red. And we add our bend points, just like that. Okay. And then we repeat that step for the negative. So from the negative on the right-hand side to the negative on the left-hand side of the breadboard. And again, change that wire color to black. And add our bend points. Don't worry too much if it doesn't look like mine, okay? I can be a tad OCD about straight lines, all right? So don't worry if it's not, if it doesn't look exactly like mine, just as long as you can actually identify what the wires do, all right? Okay, is everyone okay with that step?
Yeah.
Excellent, brilliant. Again, don't worry if you don't follow on. You all will receive the PDF, and then if you're struggling to follow along with me, just go through the PDF step by step by step, and it will tell you you will complete it. Okay, and again, do not worry if you make a mistake. Right, the world of engineering is built on mistakes. If I would be worried if you wasn't making a mistake. Okay, if you're not making any mistakes, you're not pushing hard enough. You're not taking yourself out of your comfort zone. And if you're not taking yourself out of your comfort zone, you're not learning anything and you're not growing at all. Okay, so that's don't worry about making mistakes. They're a good thing, right? Okay, so we're ready to move on. Right, the next thing that we're going to add is something called a motor driver IC. All right, and this is what we use, obviously, to drive motors, all right? It's very, very bad practice to drive a motor directly from your microcontroller, essentially because the motor will draw a massive, well, not massive, but it will draw too much current, okay? And what that does, it causes the Arduino, it causes brownouts, or something called brownouts. I'm sure you're all familiar with the term blackouts. It actually causes something called a brownout, and it causes the Arduino to behave erratically, All right. So that's why we use motor driver ICs. All right. So to add a motor driver, in the component search bar on the right-hand side again, if we just type in L293D, okay, and just underneath that, you will have something called a H-bridge motor driver, okay. If we move that onto our workspace, and this is massively important, this bit, all right, we need to change the orientation of this chip or the IC. So the white spot in the corner is in the bottom right-hand corner. That's very important. Otherwise, if it's not orientated that way, you won't be able to wire up correctly. Okay. Once you've done that, we're going to then click on that, left click and hold. I'm going to move the IC over the center line of the breadboard. Okay. If you move it, if you move it just onto the right of the breadboard, every one of them pins is connected together. Okay. And if you then power that chip, it will blow up. Okay. So that's why we move it over the center line. So none of the pins are connected together. All right. I'll give it a couple of seconds to do that. Please let me know when you're ready to continue.
Okay.
Okay. How about everybody else?
Okay.
Yep. Good stuff. Excellent. Okay. So this is the H bridge, and essentially another reason why we use these H bridges on a DC motor to reverse, or sorry, if a DC motor is moving clockwise, okay, to actually move it in the anti-clockwise direction, all we do is change the polarity on the motor. And what this basically means, changing the polarity, you've got your positive and negative. If you move them positive and negatives over on the motor, it will change the direction of the motor. Okay. Another reason why we use these chips, it also allows us to change the speed of the DC motors. So to say, for example, one of these motors here is a 5-volt DC motor. If I put a potential of 5 volts onto the motor, it will run at full speed, which is approximately 143 revolutions per minute. If I then half the potential going to it, so 2.5 volts, it will more or less half the speed of the motor. That's another reason why we use these chips or ICs. When I say IC, that basically just means integrated circuit. All right. Okay, so we're ready to continue.
Professor, can you just zoom in?
Yeah, there we go. There we go. So we need to make sure that the white spot is orientated, well, is in the bottom right-hand corner, okay? And again, you can see the center spine of these. If I hover over any of these pins on the right-hand side, you can see they're all highlighted green. That basically means every one of them pins is connected together. So if I move this over here, all them 2 pins will be connected together and the chip will blow up. Or burst into flames. Yeah, I have had it happen many a time. Oh, I really have. And you will have as well. You will do. When you're experimenting, things will burst into flames. It's just one of them things. Okay. You'll see.
Okay, Professor.
Yeah. Okay, ready to go?
Yep.
Right. So the first thing that we're going to do, as we always do, the first thing that we do is we add power. Okay. So the top right-hand corner of the IC, you will see, again, if we hover over each one of these pins, it actually identifies what the pin does. Okay. So top right-hand side, it says power 2. What we're going to do, we're going to connect that one directly to the positive terminal on the right-hand side, just like that. And again, because it's positive, we're going to change that to red. All right. Okay. The next thing that we're going to do, we're going to add the grounds. Okay. With the DC circuit, you must always have a positive. You must always have a negative. Otherwise, the circuit will not work. All right. So if we just move down these pins, you will see ground. We click on that one. We're going to move that one to the negative terminal. And then we'll change that to black. And just beneath that is another ground pin. We're going to connect that one also to the negative on the right-hand side. while you're doing that, I will explain why it's got 2 grounds, okay? The reason it's got 2 grounds is if you're driving a motor up to 36 volts via this IC, it will generate a substantial amount of heat, and that's generated through friction, okay? The reason the IC has got 2 grounds is it's used as a heat sink or something to dissipate that heat, okay? Is everybody okay with that? Have we all managed to do that?
Yes.
Yes, excellent, brilliant. Everybody else okay?
Yeah.
Yeah. Brilliant.
Okay.
Yeah, okay. So the next thing that we're going to do, we're just going to basically do exactly the same thing, but on the left-hand side, okay? So again, if you hover over each one of these pins, you will notice that it's essentially just the opposite. It's just been flipped, all right? So the bottom left-hand corner is your power or power 1. We'll click on that one. We're going to move that over to the positive terminal on the left-hand side of the breadboard. And we'll change that to red. And then we'll connect up to 2 grounds again, just like that. So the center pins, they're going to go to the negative. All right. Okay, just like that. And just let me know when you'd like me to continue.
Right, go ahead.
Yep, excellent. Okay. The next things we're going to connect are something called the enable pins. Okay. The enable pins are what allow us to change the speed of the motors. All right. For this tutorial, however, we're not going to connect these to the Arduino. Because to actually change the speed of the motors, we need to use something called pulse width modulation. All right, and it's a little bit complicated to explain to you in such a short amount of time. So if you are interested in this, though, please let me know, and I have got a tutorial for you to actually work through with pulse width modulation. All right, if you're interested. But for this tutorial, what we're going to do, we're just going to connect these pins directly to the positive terminal, but therefore give them a maximum of 5 volts. All right. So the pin right next to the white spot on the right-hand side, so the bottom right-hand side, which says enable 1 and 2, we'll click on that, and we're going to go directly to the positive terminal on the right-hand side, but we're going to leave that wire color as green. Okay. And then we'll repeat that step for the left-hand side, which is at the top left-hand corner of the IC. And it's called Enable 3 and 4. And again, we'll click on that, and we're going to connect that directly to the positive terminal on the left-hand side. Okay? Is everybody okay with that?
Yes. Yeah.
Yeah. Brilliant. Excellent. Okay. Right. So I'll continue. The next thing that we're going to do, we're going to actually connect the IC to the control board now, or to the Arduino. All right. So on the left hand, so we'll start on the left hand side. All right. We're going to connect input 4, which is just above the power on the bottom left hand side of the chip. Okay. We're going to click on input 4, and then we're going to connect that to digital pin 2 on the left hand side of the Arduino, just like that. And we'll change that wire color to, we'll go in order. We'll change that to orange. And again, we'll add our bend points to make it nice and neat. Just like that. Okay. The next one we're going to do on the left-hand side again, you'll see input 3. Okay. Input 3 is going to be connected to digital pin 4, which is basically just number 4 on the left-hand side of the Arduino, just like that. And we'll change that wire color to yellow. Okay. You let me know when you're ready to continue.
Professor, can you just zoom in a little bit?
Yeah, there we go. So this is the chip. Okay. So input 4 is this one here. And again, that goes to digital pin 2, just like that. And then we've got input 3, which is in yellow, just there, and then that is going to digital pin 4 there. Now you can start to see why we changed these colors, because if they were the same color, I wouldn't be able to identify what input it was going to, or what input or output it was going to. So that's why we changed the wire colors. Okay, again, let me know when you're ready to continue.
I think you can go for it.
Yeah, go for it. Okay. So the next thing we're going to do, we're just going to repeat them steps, but we're going to do it on the right-hand side. Okay. So we're going to connect input 1, which is just above the enable pin on the right-hand side. Okay. We're going to connect that to digital pin 3. Okay. And we'll change that wire color to turquoise. That may be different for you because it may be in Portuguese. Well, it will be in Portuguese. Okay, just like that. Okay. And then we're going to connect input 2, and that's going to be connected to digital pin 5, or number 5. Don't worry about digital and analog, just number 5. Okay. And we'll change that to blue. Just like that. Okay. And again, let me know when you're ready to continue. Are we all doing? You know, all okay? You know, following along, okay?
Yeah, it's fine.
Yeah. Okay. All right. Would you like me to continue?
Yeah.
Yeah. Okay. Good stuff. Okay. So the next thing that we're going to add, we're going to actually add the motors now. So what I would usually say is in the search bar on the right hand side, if we just type in gear, which is GEAR, okay, can someone help me out with that in Portuguese, please? Essentially, it's a geared motor, or a hobby gear motor.
It's motor de engrenagem de uso.
Brilliant. There you go. Excellent. So if we type that into the search bar, and then just underneath, you will have something called a hobby gear motor. Okay. If we click on that, and then we move one over to the left-hand side of the workpiece, and then we click on it again and move it over to the right-hand side of the workpiece, just like that. Okay. While you're doing that, I'll just explain to you what these are. These are just hobbyist motors. They're quite useless, to be honest. They're just a really, really cheap 5-volt motor. Okay. The reason it's got a gearbox with it is because it's such a cheap motor. It's really, really high speed or high revolutions, but it's really low torque. Torque, you may be familiar with, but essentially it's a rotational force. So if it's low torque, you can stall the motor or stop the motor very easily. That's why you use a gearbox on it. It basically lowers the revolutions per minute or the speed and increases the torque. So you can use it on something along them lines. There we go. Okay. So the first thing that we're going to do with these motors is we're going to connect up the right-hand motor to the IC. All right. So if you hover over each one of these pins on the motor, you'll see negative and positive. All right. The first thing that we're going to do, the positive, which is the red, we're going to connect that to output 1 on the right-hand side of the IC, just like that. And we'll change that wire color to purple. And we'll add the bend point just to make it nice and neat. Okay. And the negative then is connected to the final remaining pin on the right-hand side, which is output 2. And we'll change that to pink. All right. Okay. Is everyone okay with that?
Yes.
Yeah. Okay. So the next thing we're going to do, we're going to actually repeat that for the left-hand motor, okay, or repeat them steps for the left-hand motor. So if we go to the positive terminal on the left-hand motor, that's going to be connected to output 3, just there. And again, we'll change that wire color to brown. We'll change it to brown. And then the negative is again going to be connected to the last remaining pin on the left-hand side, which is output 4. Okay. And we'll start recycling. We'll change that to orange. Run out of colors. Okay. Just let me know when you've completed that step. We're very, very close now. Very, very close. You just let me know when you'd like me to continue.
Professor.
Yes.
I just have a question because I have an Arduino and I know this controlling piece.
Brilliant.
to
I love
this
it.
piece to control motors. I would build it like in my here right now, but I'm not finding the piece that control the motor, so I don't know.
Right.
But one thing, isn't this piece can control 4 motors, right?
No, this one can only actually control 2 DC motors. It can only actually control 2 DC motors or 1 stepper motor. Okay? You can get modules like this one if you have a look at my camera now. Okay? In reality, this is what you would use. Okay? This one will only control 2 DC motors, but you can have them expanded out to 4 DC motors. Okay?
Okay.
Yeah, so the motor driver or module you're familiar with can drive two stepper motors. Okay.
Okay.
Yeah, which are very, very, very useful stepper motors. But yeah, so I'm really, really pleased that you've got Arduino. I love it, brilliant.
Professor, sorry, can you just zoom in?
Sorry?
Can you just zoom in first? Sorry, Julia, just 1 second. Can you just zoom in, Professor?
There we go.
Yeah, there we go. Julia, you can say now.
No, that's fine. I already
Are you sure?
did it. That's fine.
Arduinos, while everyone's completing that, Arduinos, please, if you're interested in anything to do with engineering or coding in any way, shape or form, buy yourself Arduino kits, okay? They contain so many different projects that you can actually complete yourselves and then build upon. And if you actually practice with these, it will set you up so well for your university careers or your academic careers. Believe me, academic and professional careers. If there's anything I can recommend to you, buy an Arduino kit. It'll set you above everybody else. You will have a head start on everybody else, more particular to the electrical and electronic engineering students or the mechatronic students. Okay. Again, you let me know when you'd like me to continue.
I think it's fine, Professor.
Let's do it. Okay. So now what we're going to do, we're going to add the sensor. Okay. So what actually makes the robot, it doesn't make it see, but what makes the robot actually avoid obstacles. Okay. And for that, we're going to use something called an ultrasonic distance sensor. Okay. So what I'll do, I'll explain how they work in a second. So in the component search bar on the right-hand side, if you type in ultra, ULTRA, this is going to be different in Portuguese. Can someone help me out with it? Ultrasonic, we're looking for. Anybody? Nobody?
It's sensor de distância.
There you go. Okay. So once you've done that, you will be faced with 2 of them. Okay. The top one has got 3 pins. The bottom one has got 4 pins. Okay. Make sure you click the one with 4 pins. It must be the HCSR04. It's got to be the one with 4 pins. Okay, so we click on that and we're going to drag it over to the screen. Okay, while you are all completing that step, I'll just explain to you how this chip actually works. You will all actually be really familiar with this sensor. Okay, if you've heard a car parking sensor, so when you're sitting in the car, when the car gets close to an object, when it's parking, you will hear beeps getting closer and closer together, or in higher frequencies. This is the sensor that actually does it. Okay, so if you have a look at the bumpers, the rear bumpers of a car or the front bumpers of a car, you will see little round circles all over the bumper. That's one of these. Okay, or a multitude of these. All right, and how they actually work, on the left hand side of the sensor, you've got a speaker. Okay, that speaker, once triggered by the Arduino, will send out a sound wave. Okay, that sound wave will travel out, it will hit an object and bounce back to the sensor, and is received by the microphone on the right hand side. Okay, and then the Arduino calculates determines the amount of time it took for the sound wave to hit the object and return to the object. Okay, and then it's a really simple equation, which is basically speed is distance over time, therefore distance is speed multiplied by time, and then that result is divided by 2. And the reason it's divided by 2 is because you only want the distance to the object, not the distance to and from the object. Okay, I hope that was clear. All right. Okay, is everyone okay with that? Has everyone added the sensor?
Yep.
Yep, brilliant. Okay, so again, first thing that we do, we power the sensor. Okay, so on the left-hand side, the left-hand pin of the sensor, you'll see VCC or power. Okay, so that's the power pin, obviously. We're going to click on that, and then we're going to move that over to the positive terminal on the right-hand side, excuse me, of the breadboard. And we'll change that to red because it's a positive. Just like that. Okay, and then we're going to repeat that for the ground, which is the far right-hand pin, or the negative. We click on that, and we go to the negative side of the breadboard, just like that. And we change that to black. And add our bend points again. Okay, has everyone done that? Everyone okay with that? Yep.
Yes.
Yes, good stuff. No one's having any issues now. It's not to worry if you are. Don't worry if you are. Again, you've got the PDF, or you will have the PDF, which you'll be able to do it yourselves, essentially. So the next thing that we're going to do, we're going to actually connect the sensor to the Arduino. Okay, so you'll see the 2 center pins. One of them says trig, the other one says echo. The trig is actually the one connected to the speaker. So if we click on trigger, okay, that's going to be connected to digital pin 13 on the Arduino. Okay, we'll add our bend points again, just like that. Okay, the next one, the echo pin, right next door to it on the right hand side. We click on that, and that's going to be connected to digital pin 12. Let's change the wire color of that to orange, just so we don't get confused. And there we go. Okay. How's everyone done with that? Have we all completed that?
Todo mundo tranquilo? Alguém tem alguma dúvida?
It's fine.
Okay.
You know, right? Yeah. Okay. Right. Okay. So that's you've actually designed your first robotic system. Okay. That is essentially this robot here. Okay. There's a couple of slight variations, but don't worry about that for now. Okay. So essentially that is that robot. Right. So now what we're going to do, we're going to move into the code. All right. So you're going to start coding now. Right. So on the top right hand corner, you'll see code. We click on code. that will open the coding workspace, okay? And what you'll be faced with something called block code or Scratch, okay? We're not going to use Scratch because that's something that primary school children use, right? We're going to actually go straight in and we're going to start using text code. The gent who actually mentioned that's got his Arduino, you've been doing this for a very long time, so well done, right? So if we click text, just like that, and we click continue, you will be faced with the text representation of the block code, all right? And this code is actually, the language that we're going to be using is called C or C++, okay? And this is a language that all engineers use. We use this daily, okay? It's used to program microcontrollers. It's used to program GUIs, graphical user interfaces, which is essentially what we're using now to code in, okay? This is the engineer's language, if you'd like, all right? So what we're going to do, the code that you can actually see there, we're going to delete that code, just like that, okay? And then I'm going to pull my chat box up. I'm going to see if we can actually copy and paste from the chat box. All right. So with an Arduino sketch, some of you may be familiar with this. You've got a minimum, an optional 4 sections or a minimum of 3 sections. Okay. The top section is where you declare and initialize your variables or add libraries if you have any of them. Okay. Don't worry about the libraries at this time. Okay, so what we're going to do, we're going to copy that code just like that. So I'll copy it and paste it into the window just like that. And then I'll copy and paste it into the chat box. Do you want me to zoom in? Yeah, there we go.
Sorry, Professor. So that's the code that you sent before?
That's the code in the PDF, yes.
Okay.
So what I'll do, I'll put it in the chat box.
Okay. Do you want me to put that? I can do it.
It's okay. I've got it. There you go.
Okay.
And I'm going to copy and paste out of this just to see if it actually enters in properly. Otherwise, it might become a problem in a second. Oh, yeah. Brilliant. Yeah, it worked perfectly. Okay. So the code that you're going to be using is in the chat box. Okay. Has everybody got that? For the gents who were speaking before about the Arduino, you could probably code better than me with this. You'll be able to give me some hints on how to do it better. Okay, is everyone ready to carry on?
Professor, please. In the PDF has many codes. Which one we should do first?
Okay, the very, very top box. Okay, so if I move the PDF just over to the screen, okay, that very, very top one. So it's declare and initialize variables. All right.
Okay.
Yeah. So that's the first thing that you will always do. Well, global variables anyway, but we're not going to go into that too much. Essentially, what these variables are, they're essentially just naming the pins that we've connected things to on the Arduino. We're naming them something that we recognize. For example, the trigger pin that we connected to pin 13, we're naming the numerical value 13 trigger pin. Okay. And I'll show you why that's useful in the next section. All right. Is everyone okay with that? Are we ready to continue?
Yes.
Yeah. Good stuff. Okay. So that's the first section. The next section is something called void setup. All right. And in this section, essentially all you're doing is telling the Arduino what you want to do with the pins that you just connected something to. So for example, the trigger pin is an output because you're sending a signal from the Arduino to the sensor to send out the sound wave. The echo pin, however, is an input because that sends a signal. The sensor then sends a signal from the, the sensor sends a signal to the Arduino. Okay, so then that's an input to the Arduino. Okay, right? As you can see, pin mode, blah, blah, blah. That's how it works. Okay, what I'll do, I'll also put that in the chat box. Just like that. Okay. Is everyone okay with that? Has everyone managed to do that? Yep.
Yes.
Yep. Okay, brilliant. Okay, so these top two sections will only run once. Okay, excuse me, sorry, I'm just getting an email. These two top sections will only run once. All right, so as soon as you power your Arduino, it'll run through these two top sections. All right, once, and then it will get to this, the void loop or the loop routine. Okay, so I'll copy and paste that into the window. And the loop routine essentially does exactly what it says. It loops. Okay, so while the Arduino has power, this will continuously run. The code within the loop routine will continuously run while the Arduino's got power. All right, so what I'll do, I've pasted that into there. I'll also paste this into the chat box now. Okay, and I'll give it a couple of minutes to actually. There we go. I'll give it a couple of minutes to complete that. And while you're completing that, I'll just run you through what the actual program does. It's really simple program. Okay. So the first thing it does, it finds a distance. All right. So that uses the ultrasonic sensor. And as I explained before, a sound wave will be bounced out, bounce off an object and come back. Okay. So it finds the distance. If that distance is less than 10 centimeters, it will print out that an obstacle has been detected. Both the right motor and the left motor will stop for 2 milliseconds. The right motor and the left motor will then move into reverse for 3 milliseconds. The right motor will then go forward and the left motor will go in reverse, which will turn the motor, the opposite way around, which will turn the robot right for 2 milliseconds. And then if the distance is anything else, the robot will just drive forward. Okay. Is everyone okay with that?
Yes.
Yes, excellent. Okay. So the next thing we're going to add code to the fourth section. The fourth section is entirely optional, and this is where we add the functions or the subroutines that actually drive for example, the motors or the sensor itself. Remember the fine distance sensor? Okay. So the first one is the right motor function. For the gent who programs Arduinos regular or has got his own Arduino, you will notice that you can actually combine these two functions. But for simplicity, I've just separated them out. Okay. So I'm going to copy that one and we'll move that in to this window. Okay, and I'll also pop it into the chat box for you. Just like that. Okay. Right, so obviously this it's called right motor, so this drives the right motor, and essentially you'll pass an argument to this function. If it's a 1, it'll go forward. If it's a 2, it'll go backwards, and if it's anything else, it will stop. Okay. The next function we're going to add is the left motor function, which does exactly what the right motor does, but the opposite way around. So it'll drive the left motor rather than the right motor. Here we go. And I'll also drop that into the chat box. There we go. Okay. Has everybody added them two functions? Are we all okay? I know I'm going a little bit fast here. We're running out of time. Everyone okay?
Okay.
Yeah. Everybody else okay? Again, you've got
Please, a minute, please.
Yes, no problem. No problem at all. You will notice also that I've wrote instructions just above what the lines of code. You will know these are instructions because they've got 2 forward slashes or 2 forward obliques. Okay. This is how you write notes in code, or sorry, write notes in C code or C++ code. Okay. So you will notice that every line of code here has been explained and what it does and why it does it. Okay, so later on, once we've completed this, if you just have a look through each line of code, it will explain to you how it works, and then you can expand on these. You can do whatever you would like to do with them. Okay, again, you let me know when you'd like to continue.
You may continue.
Okay, excellent. Thank you very much. Is everyone okay? Everyone else okay?
Yes.
Brilliant. Okay, so the fourth and final function we're going to add is the find distance function, which I explained earlier on, which is the very, very first line of code in the loop section or the loop routine. So I'll copy that and I'll paste it into the chat box, just like that. Okay, and I'll also paste it into our coding workspace, just like that. Okay, and I'll just explain what this function does quite briefly. Okay, so it sends the trigger pin low first, just in case there's been a mistake and it's been high, which basically means it turns it off. When I say low, it just turns it off. Okay, it delays for 5 microseconds. All right, it will then write the trigger pin high for 5 microseconds, or sorry, turn the trigger pin on for 5 microseconds. Then it will turn it on. It will then wait for the echo pin to receive a signal. It will, or sorry, wait for the echo pin to send the signal to the Arduino. It will get the pulse duration, which basically means how long it's been. The distance is then worked out with the formula that I mentioned earlier, and then the distance is then printed to the serial monitor. Okay, I'll show you what the serial monitor is in a second. Has everybody managed to do that?
Yes, I just have a question.
Go for it.
If you take and make the command delay, but with the microseconds thing, you don't have to put like 50 or 500.
That's exactly it. Yeah.
Okay.
So if I just obviously you are familiar with the Arduino. If I just put delay and wanted it for 5 microseconds, it'd have to be 500. Yeah, 500. If I wanted it for 5 seconds, it'd have to be 5,000. Okay?
Yes. Okay.
Yeah. That's it's a really handy function. That instead of writing thousands all the time, it's a really handy function to have.
Doesn't have to.
Sorry, 50, not 500. I've just made the mistake there. 50.
Oh, okay.
Yeah, 50, not 500. Okay. 500 would actually delay for 5 seconds because it's a microsecond. Okay, are we all okay?
Yes.
Excellent, let's do it. Right, okay. So that's it. You've actually designed the code, or you've added the code for the robot, which you can easily adapt when if you would like to add certain things. So what we're going to do now, another fantastic thing about this software, or fantastic advantage of using this software, it actually allows you to simulate or to actually run the robot in the software itself. So if you look at the top right-hand corner, you'll see something called Start Simulation. It'll be something different in Portuguese, I imagine. Well, obviously. So if we click Start Simulation, just like that, is anybody showing any errors? Is it coming up with coding errors? Anybody? No one got any errors?
No.
Brilliant. Excellent. Excellent, brilliant. Sometimes when we're copying and pasting over, we miss the curly braces. The curly braces essentially open and close a routine. Okay. If you miss one of them, it just will not work. Okay. If you miss a semicolon, it just won't work. So, just be very, very mindful of that. Okay. So as you can see, if you look at my screen now, you can see that both motors are moving in the forward direction at 143 revolutions per minute. Okay. If you've still got your coding window open on the right hand side, right at the very bottom, you will see something called serial monitor. Okay. If we click on that, what that is actually displaying there is a distance of an object from the sensor. So where's that object, right? If we click on the sensor, you will see a sound arc. If you have a look at my screen, you'll see a sound arc that's being created, and you'll see a little round circle there like that. Okay. And that circle actually represents an object or an obstacle. Okay. So if we move that circle closer to the sensor, you will see the distance in the serial monitor. Let me just lift that serial monitor up a bit so you can see it. You'll see the distance in the serial monitor change like that. So it's gone smaller, closer. So if we move that within 10 centimeters, just like that, you'll see obstacle detected, again with the distance from the obstacle underneath. And then if you have a look at the motors, you'll see the motors will stop. I know it's really quick because it's in microseconds, okay? You'll see them stop, you'll see them reverse, and then you'll see them turn right, okay? And there you go. You've actually built your first robot, or designed and simulated your first robot. Well done, everybody, okay? Has anybody got any questions about that? And I do apologize if you can hear my dogs barking in the background. Someone's knocked at the door.
Professor, my simulator, I don't know how it's called, the black thing in the middle of the breadboard.
Yeah.
Sorry, I forgot the name.
Yeah, I see, yes.
It exploded. I don't know why.
Has it got like an explosion thing above it?
Yeah.
Yeah, right. Okay. Yeah, that's what I'm saying. They explode. So that's basically simulating. So if I powered that, if I messed the connections up on this one, that would actually burst into flames as well. Don't worry about it. Okay. All that means is, yeah, don't worry about it. All that means is, if you have a look at the power pins, you've just mixed the power pins up. Okay. But again, did you receive the PDF by any chance?
Yes.
Yes. Okay. So once we've finished here, have a little look, go through the PDF again, and just have a look, and just retrace your steps, and just see where the issue is. Again, don't worry about it if you've made a mistake. You'll learn from that explosion, or that little explosion, that you'll learn never ever to connect it up that way again. That's how we learn things. Okay. So brilliant. Don't worry about it. All right. Anybody else?
I just have a code doubt. Yeah. So if you take variation, no, yeah, a variant, and make a void with it, you can. It's just to separate it from the rest of the void loop, right?
No. What the void actually is, you actually declare. So like what you're actually going into now, you're actually going into something called data types. Okay. So if you have a look at the variables at the top, you'll see just before the variable int, or it could be int, it could be float, it could be string, it could be char. Okay. And what this actually does, it declares what value is actually going to be stored in that variable. So if you've got const int, that basically means it's a constant integer, and that value, you understand that will never change. So the void, what the void is, that's when you're actually declaring I understand what you mean now. I do apologize. I understand what you mean now. Right. So the void in front of the functions, or the function declaration, that basically means that function does not retain anything at all. Okay. It's just something that you will use. All right. So for example, I had a function that I wanted to add 1 and 2 together. So, for example, I wanted to call that function add or multiply or something along them lines. That will return a value, an integer value. So I would actually go integer. I would call that integer. I don't know, add, open brackets, close brackets, and then open curly braces, close curly braces, because that will be returning an integer value. If it was returning a character value, I'd have it declared as a char. If it was returning a string value, I'd have it with a string in front. I hope that was clear. Is that clear?
Yeah, I think yes.
Yeah, it's we're getting really, that's quite a really good question. It's quite advanced, that question. If you would like any more, I was going to say this towards the end, but I have got loads and loads and loads of tutorials for you to go through if you would like to start have a go at coding a little bit more and build a few more projects within Tinkercad. I've got many tutorials for you to actually go through, and also I've also got the PDF or the guide to actually build this yourselves. So if you would like that, please let me know. Another thing I've also got, I've got some tutorials for you to actually build your own artificial intelligence systems. All right. If you are interested in that side of things, again, let me know, and I will send the tutorials through to you. Okay. Yes, sorry.
No, yeah, I would like you to send it.
Excellent. Okay, so you've got my email. Well, you will have my email address. Just email me, and I'll send it all over to you. Bear in mind, the artificial intelligence, it is not easy. All right, and you will run into problems with it. All right, but all you've got to do, I'm only an email away, and I am happy to help at any time. Okay, so just let me know if you run into any issues with it, and then we'll go through it together if you'd like.
And I've never seen someone using this type of code, because I'm a beginner yet, you know, and I've never seen this use of void, and I actually thought it was really cool. No,
excellent. Well, that's what we'll if I will definitely send you over the tutorial on this is basically C programming, C or C++ programming. It's more it's I don't know whether you're familiar with the term embedded programming. So it's essentially for embedded systems. But it's really interesting, the tutorial I'll send over to you. It takes you from the very beginning right the way through to advanced. Okay, and you just keep working through it.
No, nice.
Excellent, good stuff. Has anyone else got any questions for me? Anyone? Don't worry about it if you haven't. It's no big deal.
Yeah, it was pretty cool, Professor. It's like, oh, sorry, Isabella Silas, do you want to ask something? Anything?
Actually, I wasn't gonna ask. I just wanted to say thank you, Professor. It was amazing. I really enjoyed the class.
Oh, thank you very much. Thank you. And I'm really pleased that you enjoyed it. I love doing things like this. That's why I become a robotics engineer, because I love playing with things like this. As you can see, you know, I've got many robots sitting next to me here.
Oh, wow.
So, yeah, that's what I do in my spare time.
That's fantastic. That's fantastic. Was great, Professor. Was fantastic. Was brilliant. I'm 100% sure the students enjoyed a lot. I'm just going to do a very short closer here, and then we're done today.
Excellent. Thank you very much.
Ok. Galera, muito obrigado pela participação de vocês hoje nessa mock class sobre engenharia robótica. Eu pop-up meu e-mail ali no chat box. Então, assim, se vocês quiserem o tutorial, Pedro, Lunks, que você quer o tutorial do professor, manda um e-mail ali pedindo esse tutorial que eu encaminho para ele. Você vai receber todos os tutoriais dele, do e-mail dele, sem problema algum. Eu quero fazer um convite para todos que estão aqui assistindo. Olha a grande oportunidade que vocês têm na mão agora de trabalhar na quarentena como atividade extracurricular. Então, hoje, às 6 horas da tarde, dentro do programa do My Way, da EFIG, vamos ter um webinar aí sobre a importância de ser diferente, tá? A importância do seu portfólio, dessas atividades extracurriculares. Isso tudo conta como um ponto na universidade. Você tem que ser diferente, tá? Então, eu conto com a participação de todos hoje às 6 horas, daqui a pouco, na verdade. E, assim, ainda temos vagas para os próximos mocks, então, se vocês ainda têm interesse em participar, corram lá para se inscrever. E pode ficar tranquilo que todo mundo vai receber o PDF do início da aula, tá bom? Eu vou pedir pro professor e pra Camila mandar e eu encaminho para todo mundo que participou hoje, tá bom? Muito obrigado pela participação de todos. Eu espero vocês na próxima segunda-feira,
Como
ok?
faz para participar dessa reunião às 6?
Desculpa?
Como faz para participar desse evento às 6?
Ô, Rebeca, manda para mim um e-mail. Quem tiver interesse, vou colocar meu e-mail de novo ali.
Diego, a gente dispara por e-mail de todo mundo agora o link.
Ok.
Sim, muito obrigada.
Dispararemos para essa turma dessa classe aqui, tá bom? Thank you, Professor. Is Lara. Thank you for the class.
No problem.
Obrigada a todos os estudantes que participaram. A gente está muito satisfeito com a participação e o envolvimento de todos vocês.
Thank you very much, Professor.
For everything. Thank Diego. If you need anything, just let me know.
Yeah, and again, if you would like any more work or anything else to go through, just drop me an email and I'll be happy to help.